Okay, so like I said, the order of your 1, 2, 3, those lines doesn't matter. So you could have put T1 equal to T2 first, and then P, and then Q, whatever. It doesn't matter there. The only place where your order does matter is you have to write the angles of the first triangle first, right? And then in your final line, you have to use the order again that they gave you in this question. They gave you the order. But guys, if they didn't give us the order, would we still be able to do that, to get that last line correct? You would go, whatever order you wrote your 1, 2, 3s in, you can use that same order. So for me, it was PQT. And then I'm going to use the same order there as well, SRT. Right, so if you maybe wrote PTQ, you're going to write STR. All right, whatever your order is, you must just match it up in the other triangle as well. Guys, if that is wrong, then your fractions are going to be wrong. Okay, so that's why the order is so important, because you are going to have to use that order to set up the correct fractions. Okay, angle, angle, angle. Please remember to write that reason. And then, yeah, it was just the first two fractions was actually what they asked us to prove, right? It was PQ over SR equals QT over RT. But maybe if your order was different, it wouldn't have been the first two fractions, right? If it was your first and third fractions, you would just have to say, therefore, these two are equal. Okay, you would have to do an extra line. But what the mark would go for then would be for your reason. Okay, so that would just be a 1 mark question. Where in the second example that we did earlier, right, where we had to do a cross multiplication, it would be a 2 mark question or 3. All right, because we had to do some more things there. Okay, any questions on this one? Right, let's look at number 2. The reason why I want us to do this one is because the actual proof of the similarity is more complicated. And I want to show you guys a method to use. So the question here is to prove that triangle BEF is similar to triangle BFD. All right, so again, they have given us the order there, which makes it a bit easier. Okay, so guys, BEF is this triangle here. Let me quickly highlight it. Oh. Okay, so BEF is this triangle here, the bottom one. But then BFD is, let me use this one, is the whole triangle, which includes the blue one already. Right, so it's not so easy to see this time. Now guys, what I do suggest, when you can't just see which angles are equal to each other easily, list 3 angles and 3 angles next to each other. So I'm going to do this. I'm going to write the first triangle's name, so triangle BEF. And then I'm just going to draw a little line. And then next to it, I'm going to write triangle BFD. And I'm going to underline it. And now I'm going to list the 3 angles in BEF and then the 3 angles in BFD. All right, so let's look at angle BEF, which is this one here. So this is FBE, all right? Or EBF, whatever. It doesn't matter what you want to call that angle. EBF or FBE. Okay, what other angles do I have there? I have angle BEF there. So I'm going to list that as well. And my third angle in this triangle is BFE. Okay, now I'm going to do the same thing for the next triangle as well. So BFD is now the whole triangle. Now guys, the first angle here, angle B, do you see that it's actually that same angle? Right? So that is also EBF or DBF if you want to, but it's still the same angle. It doesn't matter what letter you put there. Right? It's this angle here. So this angle is in the blue triangle, but it is also an angle in the pink triangle. So now guys, when I'm able to prove that those 2 angles are equal, or when I know what the reason is, I'm going to just kind of connect those 2 angles. And if you want to, you can just write next to it, common. What does that mean? The angle is common. It's an angle in both triangles. Okay, so when I write my actual similarity proof, I'm going to say angle EBF is common. All right, so I'm just kind of, I'm figuring out how to prove that these triangles are similar before I actually do it. That was great. Sorry. All right, next one, BFD. Okay, we have BFD. So this is now this big angle. Hey, angle BFD. That's the next one. That one, unfortunately, is not common, but it's fine. We'll sort that out. And then the third angle that we have is BDF. Right, we already have that one pair of angles are equal because it's the same angle, so that's good. But now, guys, we still need to prove either that these two angles are equal, or maybe those two angles are equal, or these two, or those two. All right, we need to now focus in on the angles that are listed here. Yes, Yaki? Yes, we can. Good, well done. Did they tell us that AC is a tangent, AB is a tangent? They told us that, right? So we can use tan chord theorem. Okay, so what is tan chord theorem going to tell me? Remember, the angle between a tangent and a chord, so that angle there, is equal to the angle subtended by that same chord in the alternate segment. All right? Now, which one is that going to be, guys? BDF. Good. All right, so I have that so far. So BDF is over here. All right, so we're working with BDF now. Now, guys, this angle that I've highlighted here, ABF, is not actually an angle in our triangle, right? We still need to prove that BDF, so I'm busy here, is equal to one of those two. So can I now prove that this angle is equal to one of those two? How am I going to do that? Oh, we have a Z shape, right? So this angle is also going to be equal to BFE because of alternate angles. So there I have that these two angles, because they're equal to the same thing, they're both equal to ABF. They have to be equal to each other. All right, so just on the side as a reminder, I'm just going to write ABF. That's how I know that those two are equal, because they're both equal to ABF. Now, guys, how does it work again? If you have two pairs of angles equal, the third pair will automatically be equal. So we don't need to look for a way to prove that these two are equal. We're just going to say angle sum in triangle. So usually if I'm using this method, I just do like a dotted line just to connect those, just to show that that's my angle sum in triangle one. Okay, but you can also just leave it blank. You just remember the third one is going to be angle sum in triangle. Okay, but that's not a 5-line proof. That's just kind of our working. All right, so now we still have to write in triangle BEF and triangle BFD. And now we're going to list our three pairs of angles that we have there. So we're going to say EBF is common. That you don't need a reason for. Okay, you can just say EBF is common. You can write given if you want to, but it's not, it's the only one that you don't need to write a reason for. We're going to say BFE is equal to BDF. All right, now the reasons for that, right, we have to say in brackets underneath. Remember, it was like a two-step thing. So we need to say that, what's the first one? We first wrote BFE. So I'm going to say BFE is equal to ABF because of alt angles. Sorry, I'm looking at this. It doesn't really matter. But if you're saying BFE, remember that one is alt angles. Okay, so BFE is equal to ABF. And the reason for that is alt angles. I already have brackets, so I'm not going to write brackets again. EF parallel to BA. And we have that ABF is equal to BDF, and that one is because of tan chord. Or if you want to, you could have written these two lines first and then said, therefore, BFE is equal to BDF. Doesn't matter. All right, as long as you have two lines showing that link between those two angles, which is angle ABF, and you have your two reasons, and you have to have your conclusion, which is that those two angles are actually equal to each other. Then number 3, now we're going to write our third pair of angles. We're going to say BEF is equal to BFD, and the reason for that is just going to be angle sum in triangle. Therefore, triangle BEF is similar to triangle BFD, and your reason is angle, angle, angle. Alright, so guys, this method where we list the angles kind of next to each other is a method that I use for myself when I'm doing questions when there are lots of different angles that are kind of overlapping. Right? In the first question, it would have been unnecessary to do this, I think, because the angles were quite clear to see, right? Our two triangles were not overlapping. They weren't like within a circle. You'll see often, I'm just going to show you in the textbook, for example. Look at this one here. I mean, there are so many different triangles. So it's not very easy to see, because also they might ask you to work with ACD and BAC. So when triangles start overlapping and you have lots of different angles all over the place, it just makes it a bit clearer to see what you are looking at if you list the 3 angles underneath and then you can match them up. Okay. Guys, there's one more question. We still have 4 minutes, so let's quickly do that one. They want us now to prove that BF squared is equal to BD times BE. Now, what are we going to use to prove that? Our fractions, right? So we're going to say first 2 sides over first 2 sides, second and third over second and third, and first and third over first and third. So we're going to say BE over BF is equal to EF over FD is equal to BF over BD. Reason is similar triangles. Now we need to identify the fractions that we need to use, so I'm going to tick them off. Guys, BF squared is the same as BF times BF, right? So BF squared is BF times BF. So basically I need 2 BFs, which we do have. We have a BF in the first fraction and then also in the third one. And then we need a BD, which is in my third fraction, and a BE, which is in my first fraction. So I can ignore that middle fraction. All right? Now, guys, how can I go from what I have here now, if we just ignore that middle fraction, to what they're asking us to prove? I need a BF squared. How do I get that? By taking this BF and multiplying it by the other side. Right? And then I need a BD times BE. I have a BE at the top of my first fraction. So if I take the BD at the bottom of that fraction and I multiply it out, I'm going to get that. Alright, so again, just by multiplying my denominators onto both sides, I'm going to get that. You don't have to show that, guys. You can go straight to what they asked you to prove. All right, I would like you to do number 3 for homework, please, from the same exercise. So homework is number 3. Please, guys, I'm very worried that by the time you get back on Thursday, you will have forgotten what we did now. So please, number 3 is again working with some circle geometry stuff, proving similarity, and then going from there.